were to choose another reagent. So really what you're trying to do is create a good leaving group. The hydroxide is kind of poor at this, and your book, I believe, uses phosphorus trichloride. Phosphorus tribromide is also an option. To be honest, I don't know, I don't have your book with me right now, but I think they also use pyridine as the solvent, and I don't know if your book tells you that. And there's a couple of good reasons for that. So pyridine looks like that. Number one, what this will do, it's fairly basic enough such that it will help to prevent the buildup of HX, whatever, in this particular case, HCl. It helps to prevent the buildup of acid in the reaction flask. It's also kind of a poor nucleophile, so it's not going to compete, right, with your nucleophile. Whoa, it's got big. And so we can make our alkyl halide from that. What ends up happening, and how does this work actually? Because I didn't show you how that top one worked, because we've already been through how to protonate an alcohol, and we've already done, you know, an SN2 reaction in the last chapter. But what's going on with this? So we're going to take our alcohol and we're going to attack phosphorus trichloride with it. So let me draw this out. I'll just say the heck with the geometry here. Just for a second, and just focus on the attack, right? I'm going to kick off chloride here. What am I going to get? Well, I'll get this little intermediate. So here's the alcohol part. And I'm going to extend these bonds out so that we have sort of a better view of what's going on. And I'm just going to put this all together. So PCl2. What else is in the pot? Well, I've got chloride, right? And I've got some pyridine. So the pyridine is probably going to come in. Let me draw this a little more suggestively. We'll have it right side up like this. And we're going to, the whole point of having this in the flask in the first place, right, is to prevent the buildup of HCl. So instead of using the chloride to deprotonate, we'll use the pyridine. CH2, we've returned the electrons to the oxygen, and PCl2. What is this thing? This thing right here. Oh, use a different color. This, we've created a better leaving group. So we've turned our hydroxyl group into a chlorophosphite group. That's what that thing's called. And now we're going to take our chloride and let it come in and attack that carbon. And what do we get? I'll just draw it down here. That's our alkyl halide. So what are you really doing here? You're trying to create a better leaving group out of that alcohol. That hydroxyl group is not going to be the best leaving group in the world, right? Because hydroxide is a pretty strong base. I'm not quite sure if your book uses pyridine. It may just say PCl3 or PBr3. I've drawn pyridine in here. I know that it's pretty commonly used as the solvent, actually, in this reaction. If we were to have taken that hydrogen off with chloride, then we wouldn't have that chloride available as a nucleophile to attack that carbon and kick off the chlorophosphite group. So I think the pyridine is pretty important, and so that's why I'm showing it to you. I can think of another reaction that is sort of fairly similar, or at least also uses pyridine. That would be if I took, say, let's use methanol and just keep it small. So we'll take methanol, and I can react this with something called thionyl chloride. So the thionyl chloride is going to convert that hydroxyl group into a chlorosulfite group, and that can be easily displaced by a chloride anion. So again, we're going to attack with our electrons, just like we did. Right? And let me draw this out. Let's see, CH3, O. This is where the pyridine is going to come in. I forgot to lose one of these, sorry. This gets kicked off. Pyridine's going to come in. And it's going to deprotonate. And we're going to give these electrons back to the oxygen. And so you got not too big of a carbon to come in and attack here. So I've got chloride that was sprung free in the beginning. That's sort of what reminded me to go back and draw that arrow. So I'm going to attack that methyl group right there, that carbon, backside attack that, and we're going to kick this off. And when we do, I should actually draw this just a little bit more suggestively. And we're going to kick that off too. And so what you get at the end of the day, what you care about anyway, is methyl chloride. And, you know, you'll have, and so, well, you can draw these in if you like. So SO2 and Cl minus. But, so where is my chlorosulfite group? It's this thing right here. This thing. So that's the leaving group. That's better than the hydroxyl group. Again, in this case, the pyridine is sort of a poor nucleophile. It's not going to compete with the chloride. And it's also sufficiently basic such that we can use it to deprotonate that oxygen after it attacks the thionyl chloride. It helps to leave that chloride in solution, freeze it up to be the nucleophile so that we can convert essentially that chlorosulfite group, or get that thing to leave and convert the alcohol into an alkyl halide. So I think this is pretty good in terms of some examples for turning your alcohols into alkyl halides. There's a couple of other ways you can convert an alcohol into a sulfonate ester, and then move along with that. I think your book focuses on these other types of reactions because we just covered SN2 reactions in the last chapter. So these are pretty good specific examples, just like the what was it called? Oh my God. Dehydration reaction is a good example of an E1. All right, it is really late, and so I am going to stop talking now because I'm going to slowly begin to know what I'm talking about. And so hopefully these voiceover notes are helpful to some of you. I am not sure at this moment how well this is going to transfer. I think the file is going to end up being pretty big.